So we complete the square to make this trinomial a little bit easier to answer. And these are the step-by-step directions, and we're going to write it here. So rewrite all x terms on one side. Move the c term over. So again, this is the a term. There's a 1 out in front of x squared. The middle term is your b term. The number by itself without an x is your c term. So we're going to move that across the equal sign here. So we're going to add 11 to both sides. So we have x squared plus 10x equals 11. So typically when we want to make a 0, but we actually undo that in this case. And this completing the square works really well when this b term in the middle is even. When that's an even number, like 2, 4, 6, 8, 10, anything ending in the 2, 4, 6, 8, or 0, works really well. Find the b divided by 2 squared. So remember, our b value right now is 10. B divided by 2 is 5. This is b box. And b divided by 2 squared is 25. So what we're going to do is add that to each side of the equation. So add 25 to both sides, and we have x squared plus 10x plus 25 equals 36. Now we made our equation bigger for a reason. So I know that this seems complicated, but the process will become faster as we go. Write the left-hand side as the squared binomial. So this side here would factor into x plus 5 times x plus 5. So I write x plus 5 squared equals 36. So I rewrote this trinomial as a binomial squared. And the reason I did that is because I had added this 25 in there. Now we can solve by taking the square root of each side. Just like if we had x squared equal 36, we would take the square root of both sides to find our two answers. This step, we're going to take the square root of x plus 5 squared, and that kind of the square root undoes the squared there, equals, and we got to take the square root of this side, plus or minus 6. So we get two answers when we take a square root. So remember, this would have been x equals plus or minus 6. But the x is still not alone. So what we have to do now is we're going to subtract that 5 across. And where we write that, we write it in front of the plus minus sign. So this reads x equals negative 5 plus or subtract 6, which is two answers. Negative 5 plus 6 gives us 1. And negative 5 subtract 6 gives us negative 11. There are two values of x that would have made this trinomial equal to 0. So this happened to be factorable at the very beginning, but this completing the square method works for every trinomial. So again, first step is to rewrite all the x terms on one side. So that's where I moved my 11 across the equal sign in this case. We found our b divided by 2 squared by doing the b box. B was 10, divided by 2 is 5. 5 squared becomes 25. We add that to both sides. When we add it here, we made a new trinomial. So we had this with the 11 in it, but now x squared plus 10x plus 25 nicely writes to x plus 5 squared. By writing it as something squared, we can solve by taking the square root of both sides. Moving down to question number 8. I'm going to go through this process again for question number 8 here. Solve the quadratic by completing the square. X squared plus 6x plus 7 equals 0. Now, does anything multiply to 7, 1 and 7, and add to make 6? 1 and 7 adds to make 8. Negative 1, negative 7 adds to negative 8. So this is not factorable. But the b term is even, so that's where this completing the square is used. So our first step is to move our 7 over. So we're going to have x squared plus 6x equals negative 7. Now I left a little space here on purpose, and now I'm going to go do my b box. So the b value is 6. Then we find b divided by 2 is 3. b divided by 2 squared becomes 3 times 3 is 9. And we're going to add that to both sides. So we're going to add 9 to the left, and we add 9 to the right. So I'm making my equation a little bit bigger by 9 on both sides. Again, whatever you do to one side, you do to the other. And that's so I can rewrite this as x plus 3 all squared. We did one just like that over here when we practiced some factoring review. So this side rewrites to become x plus 3 all squared equals negative 7 plus 9 is 2. So now I'm at this step. Okay? And here's where we can take the square root of both sides. So square to the left, the square root undoes the binomial squared, so you're just left with x plus 3 equals plus or minus the square root of 2. And we're going to leave that radical there, okay? Because 2 is not a perfect square to come out of it, but we still need to get x alone. So just like up here, we subtracted the 5 across and wrote it in front of the plus minus sign, we're going to do the same thing here. Subtract 3 from both sides. And our final answer is going to read x equals negative 3 plus or minus the square root of 2. We're going to leave that as a radical answer. So that's the process of completing the square. First step, you move your single digit across. You complete your b box, add your 9 to both sides, which helps you rewrite this as a binomial squared. And you solve by taking what's called that square root method. Now this again is in place of trying to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This would have replaced any kind of factoring we'd done in the past. Okay, so again, completing the square, you need to move your digit over to your b box, rewrite and take the square root of both sides, and get x alone. One more time. Solve the quadratic by completing the square. Now I'm going to tell you this one, again, I'm seeing this negative 10 in the middle, but what multiplies to 9 and adds to 10 does work out. So you could factor this. So factoring is still a thing. X squared minus 10x plus 9 equals 0. X minus 1 and x minus 9 multiply to positive 9 and add to 10. Therefore, your two solutions should be x is 1 and x is 9. So some of you struggled with the factoring, and maybe we'll replace it with this completing the square. So I'm going to start by writing x squared minus 10x. I'm going to subtract 9 from both sides, equals negative 9. My b value is negative 10. b divided by 2 is negative 5. And then the last line of the b box is to take b divided by 2 squared. So against b divided by 2. b divided by 2 squared is 25. So we add 25 to both sides. This side we'll rewrite to say x minus 5 all squared equals 16. Negative 9 plus 25 is add these combined to 16. And then we take the square root of both sides. X minus 5 equals plus or minus 4. Add 5 to both sides. And again, that always sneaks in front of your plus minus sign. X equals 5 plus or minus 4 tells me 5 plus 4 is 9. 5 minus 4 as the second answer is 1. So I found both answers using two different methods. So again, this first option, I noticed it was factorable. What multiplies to 9 and adds to negative 10. We could have solved it this way, or by completing the square using the b box. Okay. So with that said, we need to go in and talk about a circle. Okay. So notes, 9.02, parts of a circle. A circle is named by its center. So this circle is called circle P. So So that's the center point, is where all those radii meet. So AP is half the length of diameter AB. A chord connects any 2 points on a circle. So DE is considered a chord. AB is also a chord. It just happens to go through the center. So it doesn't always go through the middle. So AB is a chord, also called the diameter, or DE is a chord on that picture. And what we're going to kind of look at today is how to put a circle onto a graph, right? So we've graphed lines, y equals mx plus b. That was a lot of middle school math. You graphed quadratics, y equals ax squared plus bx plus c, like that last one. If I put in the one we just finished, x squared minus 10x plus 9 from over here equals 0. So x squared minus 10x plus 9 equals 0. And I graphed it. It's going to be a U shape. It's going to come down, hit 1, loop down off my screen, come back up and hit positive 9 because our solutions were 1 and 9. Today, we're graphing something different. Center radius form for a circle equation reads like this. X minus a squared plus parentheses y minus b squared equals r squared. Okay. So notice it has a set of parentheses squared, another set of parentheses squared equals r squared. A comma b is going to be the center, and the radius is the square root of r squared, which will end up being your r value. So if I were to give you an example, if I gave us something with numbers in it, let's say x plus 3, actually let's make that an 8 because I'm seeing an x plus 3 down here. X plus 8 squared plus y plus 7 squared equals 81. Okay. This 8 as an ordered pair would become negative 8 when you solve for set it equal to 0. X plus 8 equals 0, you'd subtract 8 over, so the x value would be negative 8. Y plus 7 equals 0 would make your y value negative 7. And the square root of 81 makes your radius 9. So when we're going from an equation to identify a center point and a radius, we switch our signs to come out of the equation, and we take the square root to find your radius. So looking at exercises 1 and 2. X plus 3 squared plus y minus 1 squared equals 9. Now I couldn't go to my calculator and type this in. Okay? Reason being, in order to type something in, you need to get the y value alone. And what happens with this is y is kind of lumped into a parentheses. You'd have to undo with a radical. And we have 2 different variables, so we're not going to solve for one at a time like we just were practicing. But we kind of use this little equation to pull out our center. So the center here is going to be, if this is a plus 3, the x value is negative 3. The y value, if that's a negative 1, becomes positive 1. And the radius squared is over here. So if r squared equals 9, then our radius is 3, and negative 3, technically speaking. But when we are counting measures, we always take the positive measurement. So how we're going to graph this is we're going to start at the center, negative 3, positive 1. So that's where I put the point. And then we're going to do a radius of 3 in all 4 directions. So it's kind of going to look like a bullseye. So 3 to the right, 3 up, 3 to the left, and 3 down helps us form a circle around our center. So we're going to do that here in the grid. 1, 2, 3 to the right from the center. From the center, 1, 2, 3 up. 1, 2, 3 to the left. And 1, 2, 3 down. Then when we connect these, we want to connect them carefully enough to kind of form a little lopsided circle. Okay. There's something else we're going to be utilizing soon. And we're going to be using one of these, or one of these. They're a compass. All right. So this compass, if I Put the compass point at the center, kind of close this in enough. That's kind of all put together with a rubber band here. But you could kind of draw a circle around. This does the same thing. Okay. You're going to see these in class soon, where we put, this circle is going to be a little bit too small to draw around. Put the center of your compass right in the middle. Maybe you did this in an earth science class last year. Hold it down as careful as you can. Swing it around. You're going to form something better than what I drew to begin with. Okay, so that is this equation graphed in the coordinate plane. So looking at exercise 2, we're going to practice the same thing. X minus 2 squared plus y squared equals 16. So we identify our center and the radius measure, and then we go and start graphing. So the center is going to be 2, comma, there's nothing being added here. So the y value is going to be 0. So remember, x comma y is an ordered pair. And this right-hand side is the radius squared. So if the radius squared is 16 right now, the radius of that circle is going to be 4. So we're going to graph 2 in the x direction, up 0, and then count out 4 to the right, 4 up, 4 to the left, and 4 down from our center. We get a circle. I'm going to sketch this one a little bit better than I did the other one. Out just a smidge. Okay. So again, I lined up the center, I lined up the hole here, and then I can put my pen in and swing it all the way around to graph our circle. Okay. So again, from our equation, we can identify our center and radius. Okay. We're going to reverse that process and try to write an equation. So here for number 3, writing the equation of a circle given the center and radius. So we have a set of parentheses squared plus a set of parentheses squared equals the right-hand side of our equation. It says write the equation of a circle whose center is negative 4, 8. Well, if it's a negative inside, it was a positive outside. So if I know my center is negative 4, inside is going to be x plus 4. If the y value, so remember x and y, is positive 8, it becomes y minus 8. The radius of 9, this side of the equation is my radius squared. So 9 squared into the formula is going to be an 81. So that's the equation of a circle. Again, we start with x plus something squared, add in the middle, y and something squared equals the radius squared. So there's a little something to do to each part of the equation. Looking at exercise 4, finding the equation from a graph. So we're going to identify our center and identify our radius. So this is an application question. A certain low-watt radio station is able to be heard in a small part of the city. Write the equation for the boundary where the radio station can be heard. Find its radius. So with this said, your radio towers, your cell phone towers, all have a certain diameter or radius around where they are located. So there's been specific places that they've put pieces, again, looking at the lay of the land, the mountains and the valleys and the rivers and so on. So this center is to the left 1, 2, and then up 1, 2, 3, 4, 5, 6. So our center is at negative 1, up 6. And that radius is 1, 2, 3, 4 over. Now this could be miles. So if this is the center of town, like Felicia, it's maybe 1 mile over and 6 miles up to get that top corner northwest area for this radio station. So writing the equation, we have a set of parentheses squared plus a set of parentheses squared equals the radius squared is 16. So our x value is negative 1, so it goes in x plus 1. The y value is positive 6, it goes in y minus 6. That is the equation they're looking for. Finding the center and length of a radius given this length of an equation in standard form. So reading number 5. it reads, the equation of a circle is x squared plus y squared minus 12y equals 20. I'm sorry, excuse me, plus 20 equals 0. What are the coordinates of the center and the length of the radius? Now, this is called expanded form of a circle equation. We want the format with the set of parentheses squared plus the set of parentheses squared equals a number. So what we need to do is this little three-step process. Get all the constants to the right, meaning this 20 we need to bump across. Group together your x terms or y terms. Now here we only have one x squared, but we have two y terms. So we're going to keep those together and then complete the square from there. So rewriting our equation, we have x squared plus y squared minus 12y. And again, I'm bumping that 20 across to the other side, equals negative 20. Now, we only have a b term, okay, remember the b box, for the y values. So the b value is negative 12, b divided by 2 is negative 6, and b divided by 2 squared here is going to be 36. So what we need to do is we're going to complete the square to make a trinomial here, and we're going to add that 36 across to the other side. So we're going to add 36 to the right and add 36 to the left. Now is our rewrite stage. So our left-hand side, we're going to keep x squared alone. So our x coordinate is going to end up being 0. But this y squared minus 12y plus 36 now becomes plus y minus 6 all squared. So again, the midline of this b box is what magically goes inside here. Equals negative 20 plus 36 gives me 16. So by doing a little bit of work with the b box and manipulating the equation to add that 36 across, we now can find the center of our circle from this long equation we started with up here is going to be 0, comma, positive 6 is a y value because we're going to change the sign. And the radius is 4. So from, again, an expanded version of the equation, a little completing the square, we were able to manipulate the equation to find our center and radius. Okay. We're going to repeat that process for number 6 and number 7 as it's scrolling the whole way down. Sorry about that. So looking at number 6. Now I'm going to do myself, make myself over here a little b box for x and y. Okay. So rewriting this equation, the 15's already bumped to the other side, but I'm going to regroup my x's together. So the equation is x squared plus y squared minus 6x plus 2y equals 15. As I rewrite it, I'm going to leave a little space as well. So x squared minus 6x to keep the x terms together, leave some space, plus y squared plus the 2y, leave some space, equals 15. Now, the b value for the x term was negative 6. Negative 6 divided by 2 is negative 3. And negative 3 squared is 9. So here we need to add 9 to make that perfect square trinomial. But whatever we do to one side, we have to add 9 to the other side as well. Then the b box for the y values, we have a b value of 2. 2 divided by 2 is 1, and 1 squared is 1 again. Okay, so we need to add 1 here to each side. Again, that keeps it balanced. So we added a 9 to both sides. We added the 1 to both sides. And how that helps is this first trinomial will now rewrite to be x minus 3 all squared. This next trinomial that we rewrote by adding the 9 and the 1 to both sides is going to be y plus 1 all squared. What multiplies to 1 and adds to 2 would be 1 and 1. Equals 15 plus 10 more, because 1 and 9 is 10, gives you 25. So now we have our center will be 3, negative 1, because we have to change the signs. and the radius is 5 when we take the square root of the 25. Okay, I'd like you to be trying 7 on your own. If you need to pause and rewatch what we just did with 6, please try it. I will give you one little hint. You do need to subtract that 15 across. So if I give you a little setup, x squared, again, we want to reorganize, so minus 4x, you'll leave a little space, plus the y squared plus 8y, leave a little space, equals negative 15. And then you're going to add a couple things over to the right-hand side. So good luck with number 7. And that, along with this classwork here on degrees and radians, is your assignment for today. Thank you.